It's okay.
It's clear.
Hi girls, okay, let me try to explain the difference of period and wavelength. Okay, first thing you need to know is what is a full wave. Like, remember I told you, like, if you have a graph, okay, something like this, and you have a wave. Okay, one thing is, you must know that a full wave is either from here, one whole cycle, to here. This is one wave. Or you can see it as long as anywhere where you start. If you start here, you must go one full cycle and come back up here. This is also one wave. Okay, if say I start here, then where does my endpoint go? I'll complete one whole cycle and come back here. Okay, this is also one full wave. As long as wherever you start, you go down and you come back to the original position, that is one wave. Okay, so the difference is how to find which is the period and which is the wavelength. That's where you have to see the graph. The graph will have two different kinds. Okay, one is, I'm going to draw now, a displacement stupid pencil. One is displacement and time graph. Another one is the displacement distance graph. Okay, also wave. Okay, so you see here, both are waves, just like the first one. Okay, the only difference is here is displacement time, here it's displacement distance. So why is it different? When you have this graph where it is about time, okay, which one is about time? Is it period or wavelength? Period is how many seconds does it take to finish one cycle. So if I see this graph, one wave, one cycle. If I start from here, I go up, I come down, I come back to my starting point. This is one cycle, correct? And this is a time graph. Meaning, for example, here is 0 seconds, here is 5 seconds, here is 10 seconds. So, it takes me how many seconds to finish one whole cycle? 10. 10 seconds to finish one cycle, one wave. That means here, when you have a time graph, you can find your period, and the period is 10 seconds. So it won't matter wherever you're finding it from. Okay, for example, I continue drawing. If I started from here, okay, say I start my wave from here. To finish one whole cycle, it'll go down, go up, come back down here to the same spot, right? This is one whole cycle. How long does it take me also? From 5 seconds to 15 seconds. 15 minus 5, it's still the same. It's 10 seconds to finish one cycle. From here to here, it's still 10 seconds. So no matter where in the graph you choose, as long as it is one wave, you will find the period, because this is a time graph. This is to find period. Period is how many seconds for one wave. Now the difference of period you already found out. This is the one I showed you the example yesterday. How do you find a wavelength? Wavelength, you must look at a different kind of graph. You must look at a displacement distance graph. See here, distance, this is time. Time is used to find period. Distance is used to find wavelength. Okay, so what is wavelength? Wavelength is how far must you travel to finish one cycle. So again, maybe here I give you 2, 4, 6, 8, 10. Distance in meter. Okay, so this is 0 meter, 2 meter, 4 meter, 6 meter, 8 meter, 10 meter. How far, how many meters does it take to finish one cycle? If I started from here, I will end where? One whole cycle, I'll end back here. So how many meters is this? 4 meters. So my wavelength is 4 meters. Okay, the symbol for wavelength is this funny sign, lambda. Okay, or if you want to choose any other point, say you're starting from here. Okay, say I'm starting from here. If I end one cycle, it'll come back up to the next crest. Correct? Now what meter is this? How many meters? It's between 0 and 2. So it's 1 meter. What about here? It's between 4 and 6. So this is 5 meter. Does my wavelength change? How do I check? 1 meter to 5 meters. What's the difference? 5 minus 1? 4. It still takes me 4 meters to finish one wave. So that's the difference. Displacement time, how many seconds to finish one wave? Displacement distance, how many meters? How far must the wave travel to finish one wave, one cycle? One cycle here, one cycle here, wherever you start. As long as it's one complete wave, that distance is your wavelength. Hope you all understand.